Okay, what are the answers? Here for part A, what do we get? 1/3. 2x plus 1 to the 3/2 plus C. And part B is tricky. And the trick is to break it up. 2x over 1 plus x squared dx. And you do them separately, and you will get 3 arctan of x plus ln of 1 plus x squared plus c. Notice here I do not have absolute values. That is because 1 plus x squared is a positive number. Always. Okay. Usually you would have absolute values like, here and here, but they are not necessary in this case. Moving on, more examples. So let's do something that requires some extra work. And also some extra resilience, we'll say. I'll go with my inside function, 1 plus x squared. And then, as usual, you get dx is du over 2x. Now, I may look at this guy and this guy and say, uh-oh, I got some problems. Unfortunately, it's not as simple as that. You shouldn't always give up on your choice of u. So what I'll do is I'll simplify as much as possible, and then I will stop and see if there's anything I can do. Okay, so here we are, simplified. But I have a problem. My problem is mixed variables. Always a problem in NYB. Can I fix it? Can I make that x go away? And the answer is yes, I can. Look at this equation up here. Look at that. Can I use that rectangled equation to make the x go away? You bet your bones. X squared is equal to u minus 1. So x to the 4 is equal to u minus 1 squared. So I can plug that in to take away my problem of mixed variables. Unfortunately, it is a problem. Okay, now what? Well, I'm going to expand the integrand as much as I can. This one, root u du. Keep expanding until I get 3 terms that are all simple to deal with. Okay, on this last step, what I did is I multiplied this thing in, and then I switched to fractional exponents. Now I have 3 terms, which are ugly, but manageable. To dot u to the 5/2 over 5/2 u 3/2 over w b. I'm just grinding this out. The rest isn't very interesting, but I think I'm okay. I can plug in my u again. Remember, u is equal to 1 plus x squared. When I do the 2 times the 7 halves, I get just 7 downstairs. Similarly, you get just a 5 under here. Oh boy, I'm really mixing my notation here. Well, it's not pretty, but what should I do? Oh, it doesn't really matter. Does not matter. Sorry, I'm grumbling here because I wrote the 2/5 in front here, but I didn't write the 1/7 in front here. Oh well, doesn't matter. Okay, I'm going to double check my answer just before I move on. Yeah, looks good. Good job, Jordan. Okay, so what is the moral of the story? Let's scroll back up. The moral of the story is don't be afraid to try. Try something. Simplify as much as possible. And ask yourself, can you fix your problem of mixed variables? Okay, can I make use of this equation up here a second time? Okay, can I get some more mileage out of this equation? If I ended up with a 5 here, then I would, or a 7 or something, then I'd probably be in trouble. But because it's a 4, I was able to get a relatively simple expression over here. So don't give up. See if you can eliminate mixed variables and have fun. Just have fun. Another example. This one's pretty simple, but we're going to learn how to mix substitution with definite integrals. Okay, a definite integral is when you have these upper bounds and lower bounds. Okay, let's see how this works out. So I'm going to choose a u as usual. As usual. You get it? Usual. du dx is minus 5. So dx is equal to negative du over 5, if you like. Now, what I'm going to do is note that 1 and 2, these numbers here, are, what are they? They are x values. Okay, 1 and 2 are x values. Okay, so if I'm doing a change of variables, if I'm switching to the variable u, then the 1 and the 2, they have to change as well. Okay, so the 1 and 2 are x values, so I have to convert them into u values using this equation here. So if x is equal to 1, that gives me u is equal to, well, just plug x as a 1 in here, and you get minus 2. If x is equal to 2, that implies that u is equal to negative 7. Okay, so I'm doing what's called converting my bounds. So the 1 becomes a minus 2. The 2 becomes a minus 7. And then I proceed as before. Okay, again, 1 and 2 are x values, and then I use this to produce the corresponding u values. Now I'm just working this out. -2, -7, u is -2, du. So I get u to the -1 over -1 from -2 to -7. And what does that give me? If I plug in -7, I get, so just plug it in. Minus. Okay, using my fundamental theorem of calculus. And working things out, I got a whole bunch of negatives here. If you want, you can just say, okay, this negative is going to cancel these two. Why don't I do that? And I get another negative. Negative a seventh plus a half. So what is this? A fifth minus 2 plus 7 over 35. 14, rather. 14. And then this cancels with this, right? 5 over 5 is a 1 over 14 at the end. Okay, all this was just arithmetic with rational numbers. The important thing was the conversion of the bounds. Okay, the 1 became the -2, and the 2 became the -7, according to this formula. Okay, a couple exercises to close out. Zero, oh boy. 0 to pi sine x over 1 plus cos squared x dx. Okay, pause, copy, try. Pause, copy, try. Pause, copy, try. Pause, copy, try. Okay, what are the answers? This one ends up being, I got half 1 minus 1 over e. And here I got pi over 2. Now, for my choices of u, here I did u is equal to just cosine. So try that. U is cosine. And here you want to do u is equal to minus x squared. So u is minus x squared. That'll make it easier. If you go plus x squared, that's possible, I suppose, but not as easy. Okay, ask me about those. in class if you have trouble.